Hello everyone, my name is Choran Park. I am combined student in Process Design and Systems Engineering Laboratory of Professor Dong-Hyuk Lee in Chemical Engineering. Today I will introduce the introduction of my research field with slide titled Raman Spectroscopy as Process Analytical Technologies of Cell Culture Producing Protein Drugs for Advanced Biomanufacturing. My research domain is biomanufacturing. Biomanufacturing is a type of manufacturing that utilizes biological systems to produce commercially important biomaterials and biomolecules. More simply, biomanufacturing is to utilize cell as a factory concept to produce value-added product, and our focus is on the protein drugs production. Although there have been enormous development of technologies, biomanufacturing still have operational difficulty and complexity since there are various process parameters and cellular traits, and they significantly affect productivity and product quality during mammalian cell cultures. For example, output performance, such as key performance indicators such as protein titer, as well as critical quality attributes, are highly dependent of input conditions such as media compositions and bioreactor conditions such as pH, temperature, and dissolved oxygen. In addition, process uncertainty and perturbation often lead to the increase in the product release time and total cost. In this context, as biopharma production scale has been increased, regulatory demand for accurate analytical data have been mushroomed. Regulatory agencies like US FDA and EMA have directed the biopharmaceutical industry to improve understanding and control of the bioprocesses so that more safer and consistent biologics can be manufactured and delivered to the patient. These regulatory demands have led to the adoption of new concepts such as quality by design and process analytical technology, called PAT. In this context, there are many analytical technology which are established in biopharma industry, and one of those is high performance liquid chromatography. This is a technique to separate components in a mixture based on the interaction with a stationary phase and a mobile phase. Another established famous technique is mass spectrometry. This is a technique that involves creation of ionized fragments of the target molecule and separation of the ions according to the mass to charge ratio. These are already established in biomanufacturing industry. However, these require offline sampling and long analysis time, thus have limitation in fast response to process variations and also have risk of contaminations. On the other side, there are development of optical spectroscopy as PAT. For example, UV absorption, fluorescence, infrared absorption, and Raman scattering are the representative optical spectroscopy. Although these are not established as much as the HPLC and mass spectrometry, these have advantages. For example, require less sample preparation and Analysis can be in situ in the process and well suited to automation. Among the optical spectroscopy, Raman spectroscopy is one of the promising candidates of PAT for bioprocesses. Raman spectroscopy enables collecting Raman spectrum, which contain detailed molecular fingerprints in aqueous environment. And coupling with inline probe with Raman spec enables collecting Raman signal from bioreactor in non-destructive and non-invasive way. And also, chemometric model enables extracting process data from the measured Raman spectrum. Overall, by combining Raman spec with inline probe and chemometric model, relevant process data covering input conditions and output performance can be collected continuously and digitally transformed in order to enable the real-time monitoring of physical cell culture systems. Starting from 2011, the application of inline Raman to the cell culture process has been made, as you can see in the right graph, and in particular, and has been steadily increasing in recent years. In particular, since 2018, real-time monitoring of amino acid and product quality has been conducted. Our group also built a Raman system and is applying it to animal cell culture processes. The calibration model used in most of the study, as you saw in the previous slide, they used in the application is the chemometric model they used. Most of study used is the forward regression method, which predict the concentration value of the target material from the measured spectrum X. Partial least square regression is one of the famous type of forward inverse regression method. It is a fast and practical method that can be applied even when only some components in the sample are known. However, this method require high effort and cost to collect data set to build calibration model, and also reliability of the prediction result is lower when process variations which are not included in the calibration data set occur. To overcome this limitation, our research topic is using reverse calibration method instead of inverse calibration method. The principle of reverse calibration method is that spectrum is modeled as a weighted sum of pure component spectra. By using this, theoretically, process variation can be overcome by this method. So my research topic is applying calibration method to analyze Raman spectrum measured from cell culture processes, thus to establish robust chemometric method. In the future, this robust chemometric method using calibration classing method can be further utilized to real-time monitoring and process control in biomanufacturing processes. Thank you for listening my introduction of research field.